So right here we have two different velocity carts, and students who are in class this week are going to be using these carts to measure something about them. So if I wanted to compare these two carts, okay, and I've given you our problem. Our problem is, how would you figure out where a bullseye needs to be placed in order to have these cars run into each other? So how would you determine where these cars were going to run into each other if they were 6.5 meters apart? So what you're going to do this week is you're going to come up with the calculations and figure out where exactly two carts are going to end up crashing into each other. And then next Monday, I am going to run the test on the carts that you've told me are going to run into each other and where they're going to run into each other. So let's see, what can we measure about these carts? Could we measure how long they are? Could we measure how tall they are? Okay, do they look very different? And when we're comparing and contrasting them, what about if we measured the diameter or the radius of the wheels? We could measure those things. Those are values that you could measure, but are those values going to be valuable in helping us figure out where those cars are going to end up crossing? Okay, and so that's kind of your question. And if you're asking yourself, like, what's the most important question that should be on your mind? The most important question to be on your mind is, how fast are they going? Okay, so if I turn on this car, okay, and I turn on this car, okay, the wheels are going to be moving differently. If I start them at the same exact point, what do you observe about them? Ready? Go. Okay, what observations can you make about those carts?